Hello, this is a video on percent of change and percent error, and this is going to be on page 55 of our notebook. So what we're going to talk about today is percent change, which is where you increase or decrease from one number to another, and we want to see what that percent of the change is. So a quick and easy way to solve problems like this is you find the difference from your original number to your new number, and then you divide by the original amount. And then you just set that equal to percent over 100 and then solve as normal. When we get to percent error, so predicted versus actual, you again find the difference and then you divide it by the actual, so what actually happened in some kind of experiment or some kind of estimation. So let's practice some of these together, and then you'll do some on the inside on your own for independent practice. So this first one, $15 to $12. So I know that I'm decreasing, so I can tell myself that this is a decrease. And this is decreasing from $15 down to $12. So my difference is 3. And my original was 15 because I started with 15 and I went to 12. So my original is 15. So it's 3 out of 15. And we want to see what percent change that is. So we're going to, one second, I'm going to shut my door. So what we're going to do is you just kind of solve this as normal. So 3 out of 15, I see that that is to multiply by 5. So what times 5 gives me 100? Well, I know on the top of my head that that gives me 20, so I know this is 20%. If you want to check that with your calculator, you're more than welcome to. So there's a 20% decrease going from $15 down to $12. This next one is a percent increase because you're going from a smaller number to a bigger number. Okay, you still do the same steps. Okay, here what I'm going to do is I'm going to just subtract. So when you're finding the difference, just take the absolute value of it. So if you do 5 minus 6, you get a negative answer. So just take the absolute value of that, or I just take the bigger number, subtract the smaller number. Either way, we're going to get a difference of 1. So there's a $1 or 1 foot increase. And the original was 5 feet. And then percent over 100. So just setting up that proportion. So 1 out of 5, well, I know 1 out of 5 is 0.20, so I know this is a 20% chance. Or I could see that this is times 5, so what times 5 gives me 100, or this is times 20, and that's times 20. So either way, I get a 20% increase. So the first one was a 20% decrease, the second one was a 20% increase. Okay? All right, so some 2 word problems that go along with your percent change. So example 3. In 1990, the cost of a movie ticket for an adult was $4. The average cost today for an adult movie ticket is $11. By what percent has the price changed? So we know we're going to go from 4 to 11. So we know we have an increase in price. So I'm going to just remind ourselves that this is an increase. Okay. The difference is, well, to go from 4 to 11 is a $7 difference. So that's going to be our numerator. So that's what's changing. Sorry, my pen's running out. There we go. My original cost was $4, and it is okay if your denominator is smaller than your numerator, okay? So then we have this, this percent setup. I see a relationship here of times 25, so I could do 7 times 25 and get my percent, so 7 times 25. And I get 175%. So ticket sales prices for adults have increased by 175% since the year 1990. Example 4, the population of Brown Middle School in 2005 was 1,100 students. Now the population is 720. So it's decreased. Maybe there's been more schools that have been built. Who knows what the reason is, but the schools have, lost some students that are going there. So we want to see what the percent of decrease is. It already tells us this is a percent decrease, so we don't have to necessarily write the decrease. So we're going from 1,100 to 720. So we need to find that difference. I don't know what that is off the top of my head, so I'm going to use my calculator. So I know that I'm going to subtract those 2 and get 380. So I found the difference of 380. Okay. And then the original was 1,100. So that's going to be my denominator. So all I'm doing is just using this as a reference guide. So I found my difference and I put it in my original. And then I'm going to set that equal to my percent over 100. If you're using the proportions, keep going. If you're using the equations or the decimal way to find percentages, that's fine as well. So 380 divided by 1100 gives me 0.34545454, blah, 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 and then multiply by 100. So I get 34.54 repeating percent. I don't know if it tells us to round to the nearest anything, so let's just round to the tenths, just to kind of make it a little bit nicer. Okay, because it didn't say anything, either of those answers is fine. All right, so that's percent change. All right, percent error is pretty much identical to percent change. The only difference is now you're talking about prediction versus what actually happened. So really, let's just kind of dive in and do some problems. So a student made a mistake when measuring the volume. He found the volume to be 65 liters. However, the actual, so he thought it was 65. The actual volume is 50. So he was off by 15 liters. So that's my difference. So you take the 65, subtract the 50, and that's where you get the difference of 15. And the actual is what we want to use as our denominator, so that's 50. So notice how, don't get tricked, notice how the 65 was said first. That doesn't mean you use it. Just because a number is said first in a sentence doesn't necessarily mean that's what's going to be used in the problem. So just remember it's difference over actual. So what actually happened in this problem, it was actually 50 liters. And then that gives me my percent over 100. I see a relationship times 2 here, so I'm going to multiply that by 2 here, and I get 30%. So he was off by 30%. Okay. All right. Example 2, a man predicted his height to be 6 feet tall. However, after he went to the doctor, he found his real height to be 5 feet. Ooh, that's a big mistake. That's a lot of difference right there. So he realized his real height was 5 feet. So what was his percent error? So he was off by a foot, right? He was actually 6, or was he actually 5? He was actually 5. So that's what we're going to take it out of. And that's my percent over 100. I see that that's times 20, so times 20. So he is off by 20%. Okay. Example 3. I thought 70 people would turn up to the concert, but actually 80 in fact did. So what was my percent error? Well, I thought 70, actually 80 happened, so the difference here is 10. And the actual is the 80, so that's what I'm going to use. And then I get my percent here. So I see that this is times 8, and this is times 8, but I don't really see how to do that. Well, I guess I could divide by 8, divide by 8. So 100 divided by 8 gives me 12.5. So I was off by 12.5%. So kind of simple, again, very similar to percent change. So let's do 4 more together, and then your goal is to do all of the inside in here. Okay? All right. So down here, Tom was making $15 per hour. He received a 4% increase. What's his new hourly rate, wage? So this is going to be a little different than here. This time they're actually giving you what the percent increase is. So he was making 15 an hour. So that's the original. We don't know what it's bumped up to. Okay, we know that he's increasing it by 4% though. So that is out of 100, right? So then we can do your cross multiply and solve. So 15 times 4 is 60. Divide by 100 gives me 0.6. So he's increasing by a big old 60 cents. Okay. So that's not his new hourly wage. That's how much he's increasing his wage by. So we're going to take the $15. We're going to add the 60 cents. So his new wage is $15.60. Okay. All right. Students calculated the circumference of a globe to be 60 centimeters. The accepted circumference of the globe is 63 centimeters. Find the percent of error. So here, the wording, it doesn't necessarily say which one is the actual. It kind of beats around the bush. So it says students calculated the circumference to be 60. The accepted circumference of the globe is 63. So 3 is our difference. And then we have to decide, well, which one is the actual. So the way that I'm reading it is the students calculated. So calculated means that they're kind of, they are like kind of guessing. So to be accepted is, I'm going to say that's what it actually should be. So 63 is what the actual should be. Or am I getting this mixed up? You know what, let's do it both ways just because I feel like I might be messing it up. Because I don't think that I'm reading this correctly. So, and you know what, this would be a good discussion tomorrow. So let's talk about this tomorrow and see how we do. So if we did this problem, we would get 4.76% off. If we did it 3 out of 60 is what percent? So 300 divided by 60 is, so this would be 5%. I think it's the 60 because they actually calculated it to be, where they're saying it should be 63, but the actual is 60. So I'm going to go with this one, but let's talk about this when we get to class tomorrow. The next one, in the year 2000, Cary had a population of 94,536 people. In 2012, so 12 years later, the population has grown to 145,693 people. So find the percent of change. So we have to find the difference here. So we're going to take 145,693. We're going to subtract 94,536. So we get a difference of 51,157. The original was the 94,536 equals the percent over 100. So then I'm going to go ahead and find the difference there. And I get 0.54. Multiply that by 100. So Cary has increased its population by more than 50%. So 54.1%. And then D, a student determined their grade to be a 94. If their actual grade was 91, what is the student's approximate percent of error? So they thought it was going to be a 94, but it actually was a 91. So they were off by 3 points. The actual is 91, so that's what I'm going to use. So then 3 out of 91 is this as a decimal, and then to change that to a percent, just multiply by 100. So the student was off by 3 let's go to the 10th place, 3.3%. Okay. So we've done all of the front, and I know this video is going a little longer than I anticipated, but I really did want to kind of get into all the problems so that when you're doing these on your own, that you're really being successful. So pay attention to the words they're using, decide if it's an increase or a decrease, or if it's a percent error where it's actual versus predicted, and then just use the two algorithms to figure out your answers. If you have any questions, you are more than welcome to comment at the bottom or ask tomorrow in class. All right, I hope you guys have a great night. So this is the front that we did together, and then here is the inside. And here are all the answers if you'd like to pause the video and check. And then here are all the answers on the other side. If you have any questions or if you find any mistakes that I've made, please comment on the bottom, or what you can do is you can just bring it up in class tomorrow. All right, have a great night.